Welcome friends. As today's our chapter is chapter number 3, 8th standard, indices and cube root. In previous year we have studied the indices and laws of indices. In seventh we have studied indices and laws of indices. So let's have a look at have a revision of that previous year. So if we multiply same number by same number too many times, means for example 2 into 2 into 2 into 2 into 2, so I have multiplied 2 to itself 5 times, means I can express it as 2 raised to power 5, means 2 is repeatedly multiplied with itself. So how much time it is multiplied, that will be written over the top right corner of these two, that is called as index here. So this is multiplication form. Keep in mind these forms, and this is called as index form because 5 is the index. In terms of index it is written as 2 raised to power 5, though that why it is called as index form. Here 2 is called as base, 5 is called as index. So in this way we can define what is the index or indices. Now we will revise the laws of indices. Laws of indices. So very first law is product law. A raised to power m into a raised to power n. Here the base is same and the law product of two indices having different indices m and n. So we can add the indices keeping base same. So we keep the base same a, and we will add the indices. Second law is division. A raised to power m divided by a raised to power n. So we can write it as a raised to power m divided by a raised to power n. So in simple way it gives us common base a and the subtraction of indices m minus n. Numerator index minus denominator. Always keep in mind we should do the numerator index minus denominator index, whatever it may be the value. Then third one is combined product a into b raised to the power m, means here the base are different having product and index is common, therefore we can distribute this power individually to the each product content. So a raised to power m, so we have distributed a to the m to the a multiplied by b raised to power m. So in this way we can expand it. Next fourth one is very basic one, a raised to power 0 equal to 1. So any number, any real number having 0 as power, its value is always unity, yeah, 1. So this was the fourth law. Fifth law is negative index, a raised to power minus m. So we can write it as, we can make this index positive, a raised 1 upon a raised to power m. or if index is positive, we can make it negative 1 upon a raised to power minus n. So this was the fifth. Sixth is index of index. So a raised to power m raised to the power n. So we can write it as a raised to power m into n. So if the situation is like this, index of index, then directly you can multiply the index. Seventh one is index of fraction a upon b or rational number. A upon b index raised to the power m is equal to, we can distribute this to numerator and denominator, a raised to power m upon b raised to power m. Now we will see in index form of negative index form of rational number. So rational number is a upon b raised to the power minus m. So my negative means we have to inverse it. 1 upon a upon b, that is we can inverse it. Inverse of a upon b is b upon a, and then we can make the index positive. In this way, the total 8 laws of indices we studied in last year. On the basis of these 8 laws, let's recall with some proper examples using these laws. So I will write the question using, it is given in your book, using laws of indices, write proper number in the following boxes. In the following boxes. So first one is 3 raised to power 5 multiplied by 3 raised to power 2, the 3 square. So base is common 3, and we can add the index. So 5 plus 2 equal to 3 raised to power 7. Always keep in mind this index must be at the right top corner of the number, and that should be in small font size. Most of time we make a mistake that 3 raised, instead of writing 3 raised to power 7, we write it as 37, that is 37. It is wrong. So be careful about writing. Then next is 3 raised to power 7 divided by 3 raised to power 9. So it is division. So keep base same. First index minus second index, and we get 3 raised to power minus 2. 3 raised to power minus 2. That is, we can say that 1 upon 3 square. In this way, we can write it as, so third one is index of index 3 raised to power 4 raised to the power 5. So we can take a product of indices index. So 3 raised to power 4 into 5 equal to 3 raised to power 20. Fourth one is 5 raised to power negative index minus 3. That means 1 upon 5 raised to the power 3. Fifth one is 5 raised to the power 0. It's easiest one. It is always 1. Sixth one is 5 raised to the power 1 means nothing. So we can write it as a 5 because 5 raised to the power 1 means 5 is multiplied singly. No other multiplicand is there. So 5 is 5. Okay. No other times. So 7. Common index 5 into 7 and having a common index 2 equal to, we can distribute this index 5 square multiplied by 7 square. Eighth one is rational numbers index. So 5 by 7 is a rational number raised to the power 3. Here we can distribute this to numerator and denominator. So 5 raised to power 3, that is also called as 5 cube, and denominator is 7 cube. So in this way we can revise the last year. And the last ninth problem is 5 by 7 rational number and the index is negative index is equal to, we can inverse the rational number 7 by 5. So 7 by 5 raised to the power, now we can change the sign of index, that is plus 3. In this way we have revised the last year laws of indices. Now we will see what is the meaning of numbers with radical indices. If the radical indices matlabs means square root or indices in the form of 1 upon n. So meaning of the number with rational indices. So first we will see when the index is the rational number in of the form 1 by n. Let's suppose we have indices such as rational numbers, indices in rational form as 1 by 2, 1 by 3, 1 by 5 up to 1 by n. Then to then we show when we have index as 2, called it as square. Therefore when we have index, we have number root 2, the index is 1 by 2. So similarly, for example, square root of 25 is written as 25 square. Square root of 2 is written as like this, and also we can write it as in index form 25 raised to the power 1 by 2. So in general we can say that square root of a is expressed as a raised to power 1 by 2, or nth root of a is expressed as a raised to power 1 by n. So in this way we can express the radical form of numbers in index form. Now suppose, for example, 4 raised to power 3 is written as 4 into 4 into 4. That means 4 4s are 16, 16 4s are 64. So therefore cube root, therefore we can say that cube root of 64 is written as cube root of 64 is also written as 64 raised to the power 1 by 3. Note that it is always equal to 4 because 4 is the value of cube root of 64. So नेक्स्ट एग्जांपल लेते हैं. सो if 3 into 3 into 3 into 3 into 3 is equal to 3 raised to power 5 is 243. That is fifth power of 3 is 243. So we can write it as a 3 raised to power 5 or fifth root of 3. That means fifth root of 243, that is 243 raised to the power 1 by 5 equal to 3. So in this way the nth power of this radical sign, if we put it in index, we will write it as 1 upon n. Here fifth root of 243 is written as 243 raised to the power 1 by 5 equal to 3. So in general, nth root of a is expressed as a raised to power 1 by n. So for example, 128 raised to the power 1 by 7 is written in words as seventh root of 120. Keep in mind 1 upon 7 means seventh root. 1 upon 3 means third root of cube root of something. In general, a upon 1 a raised to the power 1 upon n means nth root of a. Nth root of a. For a second example, 900 raised to the power 1 by 12 means 12th root of 900. So in this way we can write these rational indices in statement form. A special note for you: note, if 10 raised to power 1 by 5 is equal to something x, then x raised to power 5 is equal to 10. So this is the root of this x. So we will now go for practice set 3.1. There are two problems in practice set 3.1. First problem is express the following numbers in index form. First one is fifth. Here the word expressions are given and we have to write in number form. Fifth root of 13 is written as fifth root of 13, or it is also written as 13 raised to the power 1 by 5. Second example is sixth root of 9. It is written as sixth root of 9 equal to 9 raised to power 1 upon 6. Third one is square root of 256. So it is written as square root of 256 equal to 256 raised to the power 1 by 2. Fourth one is cube root of 17. It is written like this: cube root of with radical sign, and with index it is written as 17 raised to the power 1 by 3. Fifth root is, the fifth problem is eighth root of 100 equal to eighth root of 100 equal to, in index form, 100 raised to the power 1 by 8. Sixth problem is seventh root of, whenever you find this root of and the previously before that the number is given, put that number in index as a rational number 1 upon n. So here seventh root of 30 means we can in radical form seventh root of 30, it is written as 30 raised to the power 1 upon 7. So in this way first problem is completed. So easy. Then second problem, write in the form. Now we have to write the given numbers in word forms, expression form. So write in the form nth root of a in each of the following numbers. So first one is given 81 raised to the power 1 upon 4 is written as, now see the number 4 and write it as fourth root of, and then write this base 81. Second problem is 49 raised to the power 1 by 2. So it is written as, right, see this number, rational number, index number, that 2. 2 means square root of 49. Only for 2 and 3 we will write the different name. For 2 we will write square, for 3 we will write cube. Third problem is 15 raised to the power 15 raised to the power 1 upon 5 means fifth root of 15. Fourth problem is 512 raised to the power 1 by 9. So look at this 9. So ninth root of 512. It's so easy. And fifth one is 100 raised to the power 1 by 19. So look at 19. So 19th root of 100. Sixth one is 6 raised to the power 1 by 7. So look at 7. 7th root of 6. In this way, we complete 3.1. Now in next video, we will see the meaning of numbers having index in rational form m by n. Thank you.